Welcome back to my video series on pointers for my data abstraction class. This will be the last video in the section on pointers, and it actually takes a little bit of a detour. Technically, I'm not talking about pointers. I'm talking about a closely related topic called references. References didn't exist in C, so they're something that's completely new, but their close relationship to pointers makes them worth talking about. So we had this picture before where we had a variable a, and we got this picture by, in addition to declaring a, we declared a pointer b to point to a. And that gave us this part of the picture over here, where we have b now points to a, and a stores the value 42 in it. The declaration of a reference would be very similar, but not quite the same. Instead of using the star, we use an ampersand here. Yes, unfortunately, ampersand is used in too many ways in C++. It's used as the address of, it's used to declare something to be a reference. It also is used, as you know, when you have two of them, for the and. If you only have one, it's a bitwise and. So yes, ampersand is used in too many ways, but you can generally tell what it's being used for based upon the context. In this case, because it's associated with a variable declaration, we know that this stands for a declaration of a reference. And we can set it equal to our value a here. And the question is, what exactly does this mean? So this line here, b points to a. And that's what we showed here. B is actually storing the address of a in memory, where a is located in memory, and so it's a pointer to it, and we can get to the value of a through that pointer. This line here does something fundamentally different. Really, it does this. It creates d as an alias for a. So now we have two variables, a and d, and they both refer to exactly the same thing. And we can see this if we write a program to do this. We'll go ahead and start off with our include and our using statement. Okay, and we can put in code very much like what we had. Int a is 42. We're going to make a reference d and have it refer to a, and that's really how you should read that. So we can print out the value of d, and as you would expect, when we compile this and run it, we get the value 42. And because that was the value stored in a, and if d refers to a, then printing out d should give us 42. What if we say d equals something else? So we set d equal to 99, and then I want to print both d and a. Well, kind of what you'd expect here. Because d is a reference to a, when we change d, we're changing a as well. We print out d, it's 99. A is also 99. So how is this different from a pointer? Obviously, the syntax is a little bit different. We had before that we created a pointer b and made it point to the address of a. When we wanted to change the value of a through b, we would have done something like this. Okay, this would say, follow the pointer that b points to and assign 125 into that memory location. Okay, that's how we would read this line right here. Whereas when it's a reference, we don't need that star. Basically, the reference is automatically dereferenced. But this actually has a significant implication to it as well. So do? 16. Okay. So if I create another integer c, one of the things that we can do with a pointer is I can set b equal to the address of c. So I've now changed what b points to. In our picture here, I can move this pointer. I can alter the address and make it so this points to something else. Well, here, this is the line that does that. I can't do that with a reference because this line here, where I set d equal to something, I'm actually storing the value into a. There is no way for me to change what d references. And so in general, a reference, when you create a reference, A, you have to give it a value. You have to tell it what it is referencing. And B, you can never change that. So after you've created your reference, it is always bound to the same memory location. In fact, we can kind of show this explicitly by printing out the address of both D and A. And what you get is they're the same. So in this usage right here, D has the exact same memory address as A. And that's the way they're actually implementing the references. It's possible in some situations references might be treated in the background as pointers. That doesn't really matter to you. What matters to you is that you get an indirect reference to another memory location, and you can do things like assignments to it. We're going to come back in a later video series when I talk about passing conventions in C++, and at that point we will revisit pointers and references because they're both very significant in how we pass values around. That's it for the pointer series though. See you again later.